Hey guys, this is 5.4, Systems with Special Solutions. Up to now, all the systems that we've been working with have been the first type. They're two lines that intersect at one particular point on the coordinate grid. When systems intersect at one point and you get one ordered pair, that gives you one solution. The lines intersect. But it is possible for other types of solution. For example, if you have two lines that are parallel on the coordinate plane, they're never going to cross. Therefore, there's no solution. You're never going to get an ordered pair that indicates where they cross like you do when there's one solution. So parallel lines have no solution. The third example is when you have two lines that lay directly on top of each other. So even though you only see one line here, when we get down to the example, you're going to see that you could have two different equations that will plot the exact same line on the coordinate plane. And when they're on top of each other, you have an infinite number of solutions. The lines are the same. So let's look at our example when we get one solution. I've got a couple terms here. 3x plus y equals negative 4, and 6x plus y equals 8. I don't have opposites, so I'm going to need to convert one of these terms to opposites. So what I'm going to do is I'm going to work with my y terms since they'll be the easiest to change, and I'm going to change them to one of these terms into a negative. So I'm going to take my first equation, 3x plus y equals negative 4. I'm going to multiply it times negative 1. So negative 1 times 3x is negative 3x. Positive y times negative 1 is negative y. And negative 1 times negative 4 is 4. Cross that out so we don't get confused and bring down my second equation, my 6x plus y equals 8. I'm going to combine my equations, so I have negative 3x and 6x is 3x. Negative y and positive y cancels out. Bring down my equals. 4 and 8 equals 12. So I get 3x equals 12. Divide both sides by 3. And I get x equals 4. Then I'm going to substitute. So I'm going to bring down one of my equations. I'm going to take, let's do 6x plus y equals 8. Substitute 4 for x. So 6 parentheses 4 plus y equals 8. 6 times 4 is 24. Plus y equals 8. Subtract 24 from the left. Subtract 24 from the right. Let me bring this down. And this cancels out, and I get y equals negative 16. So my ordered pair, I do get an ordered pair. I have an x value and a y value, is 4, negative 16. So this is where those two equations would cross on the coordinate grid. Therefore, I have one solution. Okay, our next example is going to give me no solution. So I have y equals 3x plus 1 and y equals 3x minus 3. Since these are both in slope-intercept form, I can start with that y equals y, which means that 3x plus 1 is equal to 3x minus 3. Now I'm going to get all my variables on one side of the equation and constants on the other. So I'm going to subtract 3x from the left, or rather the right, and the left. This cancels out, and I get 1 equals negative 3. I've got nowhere else to go here. I have 1 equals negative 3, and this is not true. Therefore, there is no solution. Another way to look at these, if I look at this equation, right away there's actually a way you can tell that there's going to be no solution. Notice that they both have the same slope. They both have a slope of 3, but their y-intercepts are different. So when you have two equations that have the same slope but different y-intercepts, you know they're always going to be parallel and they're never going to intersect. So whenever you have two lines that have the same slope but a different y-intercept, that means they're parallel and there will be no solution. Okay, our last example has infinite solutions. So I've got 2x minus 4y equals 10 and negative 12x plus 24y equals negative 60. I'm going to solve this with elimination. I have both opposite signs for my x terms and my y terms. So I'm going to turn this 2x into a positive 12x by multiplying this equation by 6. So I'm going to bring it down. 2x minus 4y equals 10. Multiply times 6. 6 times 2x is 12x. 6 times negative 4y. Let me fix that x there. Negative 24y. And 6 times 10 is 60. I bring down my second equation, negative 12x plus 24y equals negative 60. 12x minus 12x is 0. Negative 24 plus 24 is 0. 60 minus 60 is 0. So I get 0 equals 0. When you have the same value on both sides of the equal sign, that means that you have infinite solutions. Really, these are both the same lines. If you plotted 2x minus 4y equals 10 and negative 12x plus 24y equals negative 60 on a coordinate plane, they would lay directly on top of each other and have an infinite number of solutions.